These are the solutions for the study guide for Chapter 4, Section 2, Extension, and Chapter 4, Section 3. So let's take a look at the first problem that we'll end up seeing on the test, and it says the equation of a line equals y equals 2x minus 3. And then it says to write an equation of a line that is parallel. So we have to know something about parallel lines. And what we ended up noticing about parallel lines is that parallel lines have the same slope. And so let's write that part down. Parallel lines have equal slope. Equal slope. And so that's what we're looking for. So let's take a look at that equation, y equals 2x minus 3. And what we ended up seeing in the lessons is that whenever we go ahead and graph this point, we always have to multiply the x value, the input, by 2. And then we go ahead and subtract the 3. So when we multiply by 2 every time, this is the rate of change. And so the rate of change, or another word for the rate of change, is the slope of the line is 2. And so 2 could be written as a fraction as 2 over 1, and that tells us what to go in the y direction, what to do in the x direction. So 2 is the slope, so we just need to write an equation that is parallel to it. So I have lots of different options here. As long as I have y equals 2x, I've got the answer correct. Now again, I could go ahead and add in another number here, plus 1, but this number here could vary, can vary. And so it could be any number that's added or subtracted from the 2x, but you must have this section right here, y equals 2x, for the line to be parallel. So then we look at an equation that is perpendicular. Perpendicular, we had another rule. So we end up seeing that perpendicular lines, have two parts to their slope. First of all, they have opposite, we'll say perpendicular lines have opposite sign and reciprocal. So opposite sign and reciprocal slope. So let's take a look at the equation again that we're given. We're given this, y equals 2/3 x minus 3. So again, what changes x every time? 2/3. We always divide by 2, multiply by 3. So what that means is that my slope is 2/3. I need the opposite sign. So my perpendicular slope, and here's my symbol for perpendicular. So perpendicular slope, there's the perpendicular symbol, M stands for slope, is going to be the opposite sign and reciprocal. And one thing we'll notice about perpendicular slopes is if you take the product, if I take 2/3 and multiply it by -3/2, I always end up with -1 every time. And so that's what you can look for if you're given a slope and you find that it's perpendicular. The product should make a -1 when we multiply them. So an example would be y equals -3/2 x. So I need this. This is the important part. And then you can add in any extra number, plus 1, plus 2. It doesn't really matter as long as you have this part right here, and that would be the answer. So this number here can vary. So looking at this one, it says draw a line that is parallel to the one shown. Why are the lines parallel? So when I look at this, I look and it seems that the slope is always going up 1, 2, 3, 4 spaces up and over 1, 2, 3, 4, 5. So the slope equals 4 to 5. And so I need to have that same slope. So I'm just going to raise this point up a couple points and raise this one up a couple points, and I should have the same slope. Let's check. See, if I go up 1, 2, 3, 4, I would end up having to go over, I end up going over 5. And you can see that. Again, I go up 1, 2, 3, 4, and then I went over 1, 2, 3, 4, 5. So one thing you could do for this problem is if you just bring up the points the same number of spaces, you'll end up with parallel lines. So again, you could have done many different ways to draw this. Again, this can vary, the line that you end up drawing, as long as your slope is 4/5. And so why are the lines parallel? And what you would say is the lines are parallel because the slopes are equivalent. So you could say they're the same, equivalent means the same thing. So again, if you bring the points up, and that's what I'll be looking for when I'm grading the test on this type of problem, is that I would look to see, did you bring the values, those points up, the same number of spaces? And if you did, then your slope is going to end up matching as well. Let's take a look at the next problem that says the cost y in dollars for x kilowatts is represented by the equation y equals 0.2x. Label and graph the axes and graph the equation. So label the axes, graph the equation, interpret the slope. So it tells me that the cost is y in dollars. So here's the y-axis. So we're going to put cost going down along the y-axis. And for the x-axis, it's kilowatts. So kilowatts. And then we can go ahead and number some values. Now, when I look at this slope, and when I'm going to go ahead and graph that, y equals 0.2x, sometimes it's easier to change this to a fraction, because fractions are how we end up using the slope to, or using the slope to end up graphing points. And so this is the same thing as 2/10 x, which is the same thing as saying y equals 1/5 x. And so I'm going to look at that. I have to go up one space and over 5. And so I'll just go by ones here. So this is like 2, 4, 6 here. And then I'll just go by ones here. So 2 spaces up, we'll call this 4, 6, and so on. And so when I graph this, my first point is going to be here at the origin. Because if I plug in 0 for x, that'll give me 0. And then my next point is going up one space over 5 spaces. And then I could do another one, but I'd end up running out of room. So this is just one way to graph it. As long as the line matches the equation, it is good. So you could have used different intervals, and then maybe the line would be sloped a little bit different, or at least at a different angle. But the slope would still match, because as long as the units match what the slope is, it is good. And so we've now labeled the graph by putting the labels here in the intervals. Now we've graphed the equation, so that's done. Now we have to interpret the slope. And so the interpreting the slope is looking at this portion of it right here and telling me what the 1 represents the 5. Well, the 1 represents the rise, so that's the cost. So I would say the slope represents $1. Again, it was 1/5, so $1 for 5 kilowatts. And that would be an interpretation. So you're looking at the numerator and denominator and telling me what that is with respect to the y and x axis. Here it says the amount C in dollars is proportional to H hours you work. On Monday, you earned $54 for 6 hours. Okay, so they have this equation, C equals, and then the slope. This is the constant of proportionality here, times by h, the number of hours. So we don't know what the slope is. We don't know that constant of proportionality yet. So we're going to find out what it is. I'm going to plug in 54 in for C, and then I've got my m value here, and my h value, I have to plug in 6 hours. So now I'm ready to divide. Divide by 6, and I'll find out my value of m. So m equals 9. And so now I can write the equation. C equals 9h. That's part of it now. So let's see what else it says. It says write an equation to represent the situation. Interpret the slope, and then find the amount. So now I have to interpret the slope. So the slope, again, is 9. 9 is, and then remember it's y over x. So 9 over 1 is what that slope is. And so 9 represented the y value, which is dollars, $9. And then for 1 represented hours. And so that's what we need to use in our interpretation. So we say the slope represents earning $9 each hour. So again, the interpretation of the slope is just looking at what the x and y values are, noting that the y value is on top of the fraction, x value is on the bottom. And then it says, and find the amount earned after 40 hours of work. So now we have to find, so 40 hours of work. So I have C equals 9 times by 40. So 9 times 4 makes 36, and add a 0, and that gives us our answer. So $360 after 40 hours. So on this one it says Ed works 40 hours in 5 days. Sue works Monday through Friday, and this is the graph showing here. In the coordinate plane, label the axes and graph the equation, and then we have to do some comparisons. So let's do that first. Label the axes. So when we look at this, number of hours worked, 40 hours of work for 5 days, the number of days is going to end up affecting the number of hours that you end up working here in this case. So I'm going to end up putting my days down here, and I'm just going to number those like 1, 2, 3, 4, 5, 6, 7, 8, and then the y-axis is the number of hours. I'm going to label it going down this way so I can fit it here. So this is the hours worked, and I have numbers now. I got to get up to 40 hours. So I'm looking at this, I'm thinking 5, 10, 15, 20, 25, 30, 35, 40. So I can go by fives here. So this is 10, this is 20, this is 30, and 40 hours put me right at the top. And so Ed works 5 days, and he worked 40 hours. So 5 days, 40 hours. There's Ed's line right there. And so I'm going to go ahead and put an arrow there, and then just write Ed here. And then it says that Sue ends up working 1 day at 7 hours. So 1 day is 7 hours, so a little bit less here. So it's going to be somewhere right in that region. And then 2 days is 14. And then we have 14, and actually is a little below that point there, because that would have been 15. So I'm going to go right about there. And then 3 days was 21, so right about there. And so we're going to go ahead and draw that line. And so it's going to look something like this. And that is Sue. And so now we need to, who works more hours per week? And so in 5 days, we want to find out how many days or how many hours Sue's going to end up working. So if we just start with the number of hours equals a constant rate of proportion for the number of days worked. And so if I look at this, try to find what her rate is, if I know that 1 day she ends up working, and she ends up working 7 hours, so that means when I divide by 1, her constant proportionality is going to be 7. So for Sue, her equation would go this way: H equals 7 times the number of days. Well, if I multiply 7 times 35, that's going, 7 times 5, let's just go with 5 instead of 35. 7 times 5, that gives me 35 though. So in 5 days, Sue only works 35 hours. And so Ed works more, and the reason also, if we look at the number, just looking at their lines, his graph is steeper. Ed works more because his graph is steeper, and because, we'll say, works more because his graph is steeper, which is due to the greater slope of his line. And that is doing this next part, which was who works more per hour. So we said that Ed does. And compare the steepness of the graphs. What does this mean in context of the problem? And so the steepness means that Ed works more because his graph is steeper. He works more per hour because his slope is greater. So let's take a look at the last few problems here. On this next one, we are taking this number of birthday cakes, and we're substituting that cost of $395 into C, because it says here the cost in dollars of making N birthday cakes is represented by this equation. So $395 equals 24N plus 35. So we're just going to do some opposite operations here. Subtract 35 from all sides, and I'm left with 360 equals 24N, and then we'll just do that division. So dividing by 24 on both sides, leaves me with 15. So it looks like 15 birthday cakes. Alright, so let's take a look at the next one. Here we have to find the measure of the interior angles. And so since there are two x's, I'm going to write 2x plus 102 equals the sum of all the angles in a triangle make 180 degrees. And so I'm going to subtract that 102 from both sides. And that's going to leave me with 78 equals and 2x. So I divide by 2. And that's going to leave me with x equals 49 degrees. And so I know this angle is 49 degrees. And this angle over here is 49 degrees. And then the other one is given to me at 102 degrees. So this next one says find the measure of the exterior angle. So what we have to remember is the exterior angle formula says that you add the two remote interiors and they equal the exterior angle. So we have to add the 87 and the 7. And that leaves us with 94 plus the a equals 3a. If I subtract that a from both sides, it leaves me with 2a. So 94 equals 2a. And when I divide by the 2, well, 2 goes into 9. We have 4 times with 1 left over. It goes into the 14. We have 7 times. A equals 47. But that's not what they wanted altogether. They want to know what the value of that exterior angle is. And so when we go ahead and multiply 3 times 47, or 3a, so 3 times 47, we end up with a 21, carry a 2, that makes 141 degrees. So this exterior angle is 141 degrees. And it says a car can drive 60 miles an hour, right, and solve an equation to find the number of hours it can travel in 360 miles. So we use this little formula, distance equals rate times time here, and 360 equals the rate at which it travels times by time. So there's my equation. So there's a few ways you could have set that up. We could have just known that, okay, well, I just divide the rate by the into the number of miles, and that gives me time. So I'm looking for some sort of variable in the problem, and tell me what the variable is. T equals the amount of time, and that's going to be time in hours. And so I go ahead and do the division, and it looks like it's going to be 6 hours is our answer here. So those are problems that you'll see on the test. Good luck.